if they won't ask you like using a particular method, you can use any of these two methods which is easy for you. You can use any of the methods and you can solve your question. So if they specifically ask you the procedure, like specifically they will ask you use a myhill nerode theorem or use a general method or equivalence method, then you have to follow the method itself. So this is a second method for minimizing a given finite automata. So this is a question given for you. So here A is an initial state and we can find out here C, D and E are the final states. So now you're finding small a is an initial state and then small c, D and E are the final states. So now you're getting the possible inputs are zeros and ones here. So they're given a transition. So depends on that transition diagram. You have to draw a transition table first. So this is a transition table that represents the given transition uh, diagram or a state diagram. So now we go with an algorithm first, then we are going to solve this particular problem and try to minimize it uh, as possible. So the first step is you have to create all the states involved in a given finite state machines. Like you have to make all the combinations. Depends on that you have to create a different pairs. And in second step you have to mark it as a tick. So you can tick mark for the states like qi qj, where qi is a final state and qj is a non-final state, or vice versa. So you can take any of this like final state and non-final state, or a combination of non-final state and final state. You can take any of the combinations. If you're getting this different combination and you make that particular pair with tick mark. So if there is any unmarked pairs, obviously you are getting some of the pairs which is not getting ticked because of the reason both are involving in a final state or both are involving in a non-final states. So we have to consider those states and we are finding the transitions for those states. And now you are getting some of the other pairs. By these transitions, we have to compare whether the newly generated pairs is already ticked or not. If it is already ticked, because of that reason you can make these two qi and qj is also make it as tick mark. Otherwise, leave it as possible. And you can repeat until this step. No more marks we can made in a table. And after that we can combine all unmarked pairs and make them as a single state in a minimized finite automata. So this is an algorithm. This is a myhill nerode theorem algorithm. So or a table method algorithm. So you can write down this algorithm first and then solve this particular problem. So as of now, for constructing a table, you have to remember in a rows representation we don't have the first state. So I didn't say it's an initial state. Obviously, for every state machine, we are getting the first state as an initial state, right? So in rows representation, don't take your initial state. In column representation, don't take the last state. Remember, I didn't said it will be a final state, right? You can see all the states in a given queue, that is a set of states given in your capital Q, and you can remove the final state, remove the last state from your list. So now here I am finding C, D and E are the final states. What will be my last state here? F. So now you are finding A, B, C, D, E and F will be my last state. So now in column representation, I didn't have F. In rows representation, I didn't have A. Right. So now you can take a combinations like you can take a combination of AB or BA. So AB or BA, I'm having AB, CD. So now I am finding AB. Here it is both are in non-final state, but here I have one final state and one non-final state. And here both are in see here So now I'm taken a state A and B, right? So for this state A and B, so this state, these both A and B are non-final states, and this C and D both are a final state. So I cannot make it as right. See, I cannot make this as tick for this step, right? So now I'm taken next state as A and C. So I'm taking A and C, I'm getting B and E. So B is non-final state and E is a final state. So I have a pair of final and non-final states. So I'll make it as a tick mark here. So see here I'm getting tick marked. And after that I have a state B and C. Now you're finding B and C, A and E, D and F. So this is a non-final and this is a final. This is a non-final and this is a final. So because of that, I make it this BC is also tick for this stage. And after that, I'm considering as AD. So now I'm considering A and D. So I have states BE, CF. So I know B is non-final state and E is a final state. So because of that reason, I'll make it as AD is also a tick. Okay, and then I'm considering BD. So now I'm considering B and D. Right now I'm considering B and D. So here I'm considering B and D, A, E. So A is non-final and E is final. So we can consider it as tick mark. And after that, take a combination of A and E. So this is A and this is E. So now I'm having B and E. B is non-final and E is final. So that I'll make it as a tick mark here. And after that, I can consider B and E. So now I'm considering B and E. See here, B and E I'm going to consider. Right, B and E I'm going to consider. I have AE, DF. So now I'm finding A is not final state and E is a final state. And even though both D and D is final state and F is non-final state, I'll make this is also tick mark. And after that C and E. Now you're finding C and E. So I'm getting E, E, F, F. So both are including a final state. So I cannot make it as CD and this DE as marked, because we are getting both included in a final state. Right. So because of that reason, I cannot mark it as a tick mark here. And after that, I have a states like D and E. So D and E. So in a same situation, so I cannot make it as tick mark. So now these are unticked for the initial state. And after that, I'll consider AF. So I consider AF. So I'm having B and F. So now you're finding B and F. So both are non-final states. And here I'm getting C and F. Here C is a final state. So because of that reason, I'll make it as a tick mark here. And after that, considering B and F, right? Considering B and F. So here AF. So both are not final state, and here I have DF. So D is a final state and F is non-final state. So I'll make it as a tick mark. And after that, consider C and F. Right, for C and F, I'm getting EF. So E is final and F is non-final. So I'll consider as tick mark. And then I'm considering D and F. So now I'm taking D and F. Now I'm finding E is a final and F is non-final. So because of that reason, I'll make it as tick mark. And after that, I'm having a state E and F. Now you can see E and F here. So E is final state and F is non-final state. I'll make it as a tick mark. So because of the step 2, what it will say, if you are finding any of the transitions of two states, now the pair will consisting one from final state and one from non-final state, you can put it as a tick mark. And now by this state, what are the things that is not make it as a tick mark? You have to consider those states. Remember, this is also unmarked, because you can see for A and B, so you're getting here BA, so there is no final state. Okay, for this I'm having one final state C, right? So we have to take this one also tick mark. Okay, fine. So now in next step, by your step 3, so you have to find out, you have to check it whether it is a possible. In next level we have to make it ticks for this unchecked boxes. So for that reason, in step 3, you can consider the unpaid. See here, if there is any unmarked pairs, you can consider and find out the transitions. If you're getting a new pair, and you can verify whether those files are is already ticked or not. If it is checked, then you can make this particular state pair is also tick. Otherwise, still remains it will be unchecked. So that is your algorithm will say. Now you consider the state C and D and C and E and D and E. So here see, I'll consider CD and CE and DE. So now I'm finding the transitions for zeros and ones. I'm getting EF combination. So now you're finding EF is nothing but, so one is from initial state and another one is a final state. So now I have a states E and F, which will be my new states. But you are finding here any of the thing. Like here we have the states E and FF, right? So you can consider like this, EFF. So now a single state, I didn't have any EE combination, I didn't have any FF combination. So it is not possible to tick this states C and D. So I have to remind, I'll make it as a blank. And now I consider for C and E also, I'm getting the same way, like EE or FF I'm getting. So I didn't have any of the state which is stick with this possibility. So now it is also not possible. For D and E also the same thing I'm getting. So now, because you're finding in your transition table, you're getting for these three states with the same inputs, it is moving to the same state. Right? You're finding that. So because of that reason, I cannot reduce this. Right? So what else your last step will say? Combine all your unmarked pairs. You just combine all your unmarked pairs. What are the unmarked pairs? CD, DE and CE. So now you can make a transitions, like a transitive closure on this. Now you can make it as, if you have a relation between C to D and D to E, then it have a relation from C to E also. So because of that, you can make these three states are equal state. Like you can combine C, D, E and make it as a single state. So because of that reason, I'll make it C, D, E as a single state. Now A is an individual state, B is also an individual state and F is also an individual state. So now you are finding a transitions with zeros and ones and you are getting C, D, E as combination. So any of this character you are getting here so that you can replace with a single state. So that is of your last step will say in your algorithm. So now this is an equivalent DFA or a minimized finite automata, right? So here you can consider, so A is one state, B is another state and CD is combinedly a single state and F is another state. So depends on this transition table. I am making a transition diagram here. So with arrows. So A with 0 I am moving to B and B with 0 I am moving to A. So A with 1 I am moving to CDE and B with 1 I am also moving to CDE. And then from CDE with A I am going to take the same state. See here I left it this. So what it will say from CDE. So if it is 0, I'll be in same state and if it is 1, I'm going to F. So for F, for zeros and 1, I'll be in a same state. So like this. So this is an equivalent DFA or minimized DFA for a given question. So the same question I solved by the second method also, which we discussed as of just now. So any of the method you can follow, you will get the same answer, right?